The fraction that we have here can be rewritten as 6 plus 3x minus x squared all over x squared times x plus 2. So just rewriting the denominator or factorizing the denominator. We might be able to use partial fractions for what we have here. We have two things multiplied by one another, but we should first check a couple of things. Firstly, we should check if the numerator can be factorized, because if it can be factorized, it might be the case that one of the factors cancels out with x plus 2. So if we were to put this into our calculator and solve that quadratic, we'd get decimal roots. One of the roots wouldn't be minus 2. So for that reason, we wouldn't be able to factorize the numerator easily. So that bit's okay. So we should be able to use partial fractions. The second thing to check is the greatest power in the numerator, which is in this case 2, the same or bigger than the greatest power in the denominator, which in this case is x cubed, or to the power of 3. 2 is not the same or bigger than 3, and therefore this is not an improper algebraic fraction. If this 2, this greatest power on the numerator, were 3 or higher, then it would be an improper algebraic fraction, and then we'd have to use long division first before we can use partial fractions. But that's not the case, and we can't factorize the numerator to simplify this fraction, and therefore we can go straight to partial fractions. So the 6 plus 3x minus x squared, all divided by x squared times x plus 2, can be rewritten as a over, so because this is x squared, we'd write it as a over x squared plus b over x plus c over x plus 2. So whenever we have a squared factor on the denominator, we have to have one of the constants over that thing squared, and the other constant or another constant over that thing not squared. So for instance, if this were x plus 2 squared, then we would have x plus 2 squared and just x plus 2. Okay, now we can make a common denominator. So the common denominator would be just what we have here, x squared times x plus 2. So we want to think about now, what do we have to times or multiply by each of these fractions to get this on the denominator? So for the first fraction, the a over x squared, to get this on the denominator, we'd have to multiply top and bottom of this fraction by x plus 2. So the first term would therefore be a times x plus 2. For b, for the b term, to get this as our denominator, we would have to multiply top and bottom of this fraction by x again, because we need to get x squared. So times it by x, and then also x plus 2. So b would then be multiplied by bx, x plus 2. And finally for c, so what c is missing, or rather what the denominator is missing, is x squared. So we'd have to times top and bottom of this by x squared. So plus cx squared. This is equal to the left-hand side, so no change with the left-hand side. And then the denominators cancel, so this cancels with this, and then we're left with 6 plus 3x minus x squared is a times x plus 2 plus bx x plus 2 plus cx squared. And now we can start setting x to be things that make any one of these brackets or factors 0. Easiest one would be x is equal to 0 to start with, so let x equal 0. That makes these two terms 0. The left-hand side becomes 6, so 6 is equal to a multiplied by 0 plus 2, so 2a, and again, these two are just 0. So then we end up with a is equal to 3. We can then let x equal to minus 2, and that makes this bracket 0. So then on the left-hand side, we have 6 plus 3 times minus 2 minus 2 squared. And on the right-hand side, so again, these two brackets are now 0. Therefore, we're just left with c multiplied by minus 2 squared. Okay, so let's just tidy this up. 6 minus 4 is equal to 4c. That's just the same thing as minus 4 is 4c, so then c is just equal to minus 1. And finally, we don't have an extra term that we can set x to be to make a and c, or the terms multiplied by a and c 0, because we've already used minus 2, we've already used x equals 0. So we just set x to be something else. We can use x is equal to 1. And this will help us work out what b is. So x is 1. The left-hand side becomes 6 plus 3 times 1 minus 1 squared. And that will be equal to a is 3, remember, a multiplied by 1 plus 2, and then plus b, multiplied by x, which is 1, and then multiplied by 1 plus 2, which is 3. And finally c, which is minus 1, c is minus 1, times by x squared, which is just 1. Okay, so this then becomes 8 is equal to 9 plus 3b minus 1, and we then end up with 8 is equal to 8 plus 3b. 3b is then 0, so b is 0. Okay, so remember that this fraction here can be rewritten as this. So we just replace the a and the c with 3 and minus 1. So this then becomes, the integral becomes a over x squared. The b term was 0. Let's just look at the c term now, which is c over x plus 2. So that'll be minus 1 over x plus 2. So this is effectively what we're integrating now. So this is the same thing as, I'll just rewrite the first term as 3x to the minus 2, minus 1 over x plus 2. The 3x to the minus 2, raise the power by 1. 3x to the minus 1, divide by the new power. So dividing by minus 1, well, that'll just make this negative. And 1 over x plus 2 would integrate to make ln of x plus 2. So minus ln of x plus 2. We don't need to put any kind of factor in front, because if you were to differentiate this, it will give you exactly what you have here. So it'll be this plus c.